Now let us study the trend in the E0 reduction values of the 3D series elements from the +2 to ground state. Now what we find in the 3D series elements when we are discussing their E0 reduction values from the +2 to ground state, that the scandium is not having any value because scandium doesn't exist in its +2 state. The values varies from -1.63, vanadium minus 1.18, chromium -0.9, manganese -1.18, Fe -0.44, cobalt -0.28, nickel -0.25, copper +0.36 and zinc -0.76. So what we find is, as such, we find that the values are irregular. Why? Because these values depends on three energies. E0 values depends on three energies: sublimation, ionization and hydration, which varies differently for different elements. That's why therefore we don't have any fixed trend. But if we see these values minutely, what we find is, and if we eliminate these three elements which basically work as exceptions, what we find is that the E0 reduction values are increasing. There is an increasing values of the E0 reduction value. They're becoming more and more positive. They're moving towards positive value. The reason is because that the +2 oxidation state stability is decreasing. Why? Because the summation of the first and the second ionization enthalpies is becoming higher and higher as we move across the period. That is why what we find is the stability of the +2 oxidation state decreases. Now, that is why copper is existing in the plus value, plus E0 plus Cu2 plus 2 Cu. That shows copper +2 is not stable. It immediately gets reduced to the copper. The reason it tries to acquire 3D10 configuration. That is why it's not stable. And why we have these three having different values? Why the different in the sense that their E0 reduction values are more negative than the required or expected values. The reason is because manganese here is very stable in its +2 state because it is having 3D5 half-filled stable configurations. It doesn't get changed to the ground state. Whereas nickel, again being the very small in size in +2 state, is having very high hydration enthalpies, and zinc is already in +2 state, is having 3D10 4s0 pseudo noble gas configuration, which makes it very stable. That is why we have these three elements present in their much more negative E0 reduction values than their expected value. Otherwise the trend is as usual. Now, simultaneously, let us study the trend in the E0 reduction values of the 3D series elements from the +3 to +2 state. This I have written along with the +2 to 0 because this can be easily then compared. So now we will be discussing the trends in the E0 values from the +3 to +2 state of the 3D series elements. Scandium, no values because it's not existing in +2. Vanadium, titanium, yes, it is having -0.37. Now this minus value and this minus value shows, what we can show is titanium out of Ti +2 and Ti +3 is most stable in the Ti +3 state, because if it is taken in +2 state it will oxidize to +3, and if it is in +3 it will not get reduced to the +2 or to the ground state. That's why it's most stable in +3. Now, and what we find is vanadium very stable in -0.26 values, it's minus, which shows titanium. Vanadium again very stable in -3. Chromium -0.41, it's the highest out of these elements, which shows chromium +3 is very stable. Why it is very stable? Because in this it requires T2G3 Eg0 half-filled stable configuration in the coordination, in the formation of the coordination compounds, particularly the octahedral complexes. That's why what we find is chromium +3 is very stable. That is why chromium +2 is a very good reducing agent, because it immediately gets oxidized to what? Cr +3 to acquire this stable configuration. Then we find suddenly a great change from -0.12 manganese becomes +1.57. The reason is because this value shows that what it shows. It shows that manganese +2 is very stable, much more stable than its what? +3 state. So if I have to compare manganese +2 and manganese plus 3, what we find is plus 2 is most stable. What makes manganese plus 2 very stable? Because it has 3d5 stable half filled configuration, which makes manganese very stable. That's why its 3 to 2 reduction potential is very, very high. Now similarly, let us move to what we find is in the case of iron. Now iron is plus 0.77 volt. Yes, it is very stable in its most stable in its plus 2 state, and it immediately gets reduced to from plus 3 to plus 2 state. The reason being because of the higher ionization enthalpies, third and the fourth one, the higher ones. Across the period, what we find, the stability of the higher oxidation state is decreasing. That is why cobalt is actually having much more, minus plus 1.97, which makes cobalt plus 2 very, very stable. And we don't have such values for nickel, copper and zinc because they are not existing in their plus 3 oxidation states.